The high stand is a period of high sea level. Why we are saying? Because in this curve, this part we are saying where the sea level high is noted. And the beds deposited during period high stand systems tract. A systems tract is a term used in sequence stratigraphy for strata deposited during a stage of a depositional sequence. What is a systems tract? It is a strata deposited during a stage of a depositional sequence. So, during high stand the sediment deposited will be called the high stand systems tract. Example of a systems tract is high stand system tract. So, in this case what kind of vertical succession is expected in case of a high stand? As the curve goes like this, we are getting shallower water to deeper water deposits. So, in a simple presentation we should get progressively deeper water deposits upward. During the high stand, sediment is supplied by rivers from the hinterland, from the land portion, and most of the accumulation occurs on the shelf. Sediment is supplied by the rivers from the hinterland, means from the land portion, and most of the accumulation occurs on the shelf with little sediment reaching the deeper basin. Since during this span the water level has increased, it has more capacity to accommodate the sediments. Here itself most of the sediments will deposit, and through the slope more sediments cannot go to the deeper basin. So, in this way we have explained the high stand systems tract. We are going to see now the sequence boundary. During sea level fall, erosion of the shelf occurs as rivers erode into sediment deposited during the previous cycle. You can see that the water level was here. Now the water level has gone down to here. So, what has happened? This much of the land exposed to erosion, and the river which was earlier releasing water in the sea here has now the opportunity to come inside and erode this portion. This said, during sea level fall, erosion of the shelf occurs as rivers erode into sediments deposited during the previous cycle. Here earlier in the previous cycle, in this portion sediments were deposited and now they get eroded due to reverse action. So, this erosion creates unconformity in the vertical succession. Now, this is also called a sequence boundary. So, in the vertical succession from here we will find an erosional surface because river is eroding the sediments, and this unconformity is also called a sequence boundary. And below this is a depositional sequence, and if any deposition happens by the river, this is a new depositional sequence. We will now see a low stand systems tract. We were describing the sequence boundary and the falling stage has been described in this diagram. We are now again going to see this portion where the sea level is starting to rise. Now what will happen? What was earlier the river path, here the sea water has gone inside, and in this way the estuary is produced, and estuary deposition will take place in this place during the low stand, and the deposition is known as the low stand systems tract. We said systems tract will be added during high stand, the deposition is high stand systems tract. During low stand it is a low stand systems tract. During this time of low stand, the relative sea level is rising slowly. Here it is rising slowly, and here in future, for example in transgression, is going to rise very fast. So, when the sea level rises, basically we are breaking the incident into two parts: slow rise of relative sea level for a shorter time, and then this is followed by a fast rise in relative sea level for a longer time, and this one is called as the transgression, marked by this yellow region here, for which the transgressive systems tract has been defined. The interval of low sea level is called a low stand, and the deposition of this period is called the low stand systems tract, LST. Sediment deposited during low stand will be called low stand systems tract. Sediment deposited during high stand will be called high stand systems tract. What happens during this phase? The sea level is rising slowly, but the rate of sediment supply is relatively high. The major sedimentation that takes place right now as basin floor fan. This is the basin floor fan. Now we are going to see the transgression here, the transgressive surface, the point at which the rate of creation of accommodation due to relative sea level rise exceeds the rate of sediment supply. This is the time when accommodation rate exceeds the sediment supply, and it is given by, note the previous shoreline here, and now it has come over there. Shoreline has gone inside the landward direction. Transgressive systems tract, that means the rock record. We are talking about a systems tract. This sea level rise has formed the estuaries as the incised valleys are flooded with sea water. This was the incised valley, and now water level has gone up and it is flooded with sea water, and estuarine sedimentation happens. It is characteristic of the transgressive systems tract. Let us understand the meaning of the maximum flooding surface. As the rate of sea level rise slows down, this is the high stand. Here the rate of sea level rise has slowed down. Here accommodation is balanced by sediment supply. Rate of accommodation nearly equals the rate of sediment supply, and the shoreline farthest in the landward extent is called the maximum flooding surface. So this surface is known as the maximum flooding surface. When we have considered this part of the curve, in this context this point represents the maximum flooding surface. But if I consider this curve further, for example, then this point is not the maximum flooding surface, rather this point is the maximum flooding surface. Concentration of orthogenic glauconites and phosphorites are typical of the maximum flooding surface. Concentration of orthogenic glauconite and phosphorite is a typical indicator of this phase. During the high stand, the incised valley has been inside the sea water, is below the water level, and here no fluvial sedimentation takes place. Now we are going to see the ramp margin depositional sequence. That means the depositional sequence for this kind of geometry. The same slide is brought here, and we have changed this slide over there. These are the ramp margin depositional system. Here we can start with high stand. This is same as the shelf break example. The sequence boundary in the ramp succession. In the falling stage, there will be first evidence of erosion caused by the sea level fall. Erosion starts in the landward end first, and how the stratal geometry changes may not always be easy to find out. Falling stage systems tract. That means in the falling stage, what kind of systems tract will be found is discussed. Here the sediment is supplied by rivers from the hinterland and also as a result of erosion of the landward part of the ramp. Since the shoreline has gone down, river starts depositing sediment. So the river deposits come at the top. So if we make a succession here, at the bottom can be the oceanic sediments in general language, and over that will be the river deposits. Now let us look at the low stand. That means this portion. In the low stand, the sea has moved up. Earlier it was here, the shoreline, and now it has gone over there. It has little bit gone inside, and again estuarine deposition has happened here. The incised valley is partly covered by the sea water. Next comes the transgressive surface, transgressive systems tract, maximum flooding surface, and the high stand, which is given by this portion. We are going to discuss these two together, high stand systems tract and the transgressive systems tract. Here the processes and patterns of sedimentation during these stages are essentially same as that of the shelf break margin depositional sequence, which was described here. Although we started with a simple sinusoidal curve like this, more complexity is going to be discussed. The rise and fall of sea level rarely follows the simple sinusoidal pattern as I showed in the previous diagram, but there are punctuations by shorter periods of sea level fall and vice versa, resulting in a more complex pattern of relative sea level fluctuation given by this curve. So, it is not just like this, rather it will be several rise and falls, but overall there can be rise and there can be a fall. So, here is an overall rise and here is an overall fall. This high stand systems tract, falling state systems tract, again falling state systems tract, high stand systems tract, sequence boundary formation. These terms, many of them have been abbreviated in this diagram: HST, SB, FSST, LST, TST, FSST, SB and HST. A systems tract. That means the rock record may be divided into multiple smaller scale packages, and those are known as parasequences. Definition of parasequence is fundamental in sequence stratigraphy. Each parasequence represents deposition with a short period of increased accommodation and may occur in the context of overall low stand and falling stage conditions as well as within transgressive and high stand systems tract. Therefore, parasequences are packages of beds deposited as a consequence of the creation of the small amount of accommodation that is then filled up by sediment. So, parasequences deposited during short term sea level rise can be pointed out. Deposition that happened at these points, those sedimentary layers can be called as the parasequences. And from one parasequence to another parasequence, that means the parasequence boundaries phases shift from shallower to deeper water deposition, because as you are going from this point to that point to that point, there is shallower water, deeper water, shallower water, deeper water, this kind of alterations. Therefore, in the rock record also shallower to deeper rock alteration would be found. Nevertheless, an overall rise in the sea level can be observed. Here we are observing overall a rise in sea level. Within such rock records, such changes are expected. The surface marking the parasequence boundary is called a flooding surface, and it is not to be confused with the maximum flooding surface. Suppose it is a parasequence, then the two boundaries are called as the flooding surface. The thickness of the parasequence units, such as this thickness, can range from meters to tens of meters. It can be few meter to tens of meters. If the sea level is continuing to slowly rise during the period of deposition, as happens in a TST. What is TST? The transgressive systems tract. Each of these phases will be thicker, and this can be considered as an expanded succession within a parasequence. So, within a parasequence there can be an expanded succession, thicker unit, and that can represent the sea level continuing to rise slowly during the period of deposition. A thicker sequence identified as a single sequence will have that significance. When the sea level is falling, the parasequence formation would result in thinner units. So, if we have a thick unit and then we have a thin unit, the thin unit is probably linked with falling sea level, and the thicker unit of a rising sea level. Why so? Because during rising sea level the accommodation space increases whereas for a falling sea level it reduces. So, the chance of getting more sediments will be in case of a rising sea level.